My name is Eric Johnson. I am a Senior Developer Advocate for Serverless at AWS. This video is the first of a series designed to help you build serverless applications using the AWS Serverless Application Model, also known as AWS SAM. AWS SAM comes in two parts. The first is the AWS SAM model itself, which allows developers to use shorthand syntax to express resources and event source mappings as infrastructure as code for serverless applications. The second, AWS SAM CLI, is a companion command line interface for local development, debugging, building, and deploying serverless applications. This video focuses on introducing AWS SAM and an overview of the AWS SAM model. The next four videos cover AWS SAM CLI commands for creating, developing, and deploying serverless applications. Finally, I show some AWS SAM tips and tricks in the last video. Okay, let's get started with the AWS SAM model. The AWS SAM model is an abstract of AWS CloudFormation and uses standard CloudFormation resources to declare infrastructure as needed. Additionally, AWS SAM adds a set of serverless-specific resources that get transformed into traditional CloudFormation resources on deployment. Here I have an example of a serverless resource for AWS Lambda. On deployment, these 20 lines of code transform to over 190 lines of code in CloudFormation. From 20 to 190 lines may seem like an enormous change, because it is. This transformation demonstrates the power of AWS SAM. A serverless resource for AWS Lambda can create more than just a Lambda function. In this example, these 20 lines are creating 4 different resources. These resources include a Lambda function, an AWS Identity and Access Management or IAM role for the function, an event source in the form of an Amazon API Gateway HTTP APIs with stage, route, and integration configured to invoke the Lambda function, and an Amazon DynamoDB table for storing data. At the end of the deployment, AWS SAM has transformed these 20 lines into a public API endpoint for reading data from a backend database. Including AWS Lambda functions, AWS SAM offers a total of 7 specific resources for building serverless applications. Each of these resources will combine user input with standard defaults to generate CloudFormation resources on deployment. The following is a high-level overview of the resources. However, I encourage you to dive deeper into all of these resource options found in the docs at https://s12d.com/srv-resources. Also, as a pro tip, when searching the internet for support, use the full resource name. For example, AWS://serverless:// when searching for the serverless Lambda function resource. This advice also helps in standard CloudFormation resources. As previously demonstrated, the serverless function resource generates a Lambda function. Developers can configure function settings like runtime, memory, size, and environmental parameters. However, they can also configure settings for event source, access policies, and even configure how AWS SAM should build the Lambda function. From HTTP calls via Amazon API Gateway HTTP APIs to data updates on an Amazon DynamoDB table or object changes in an Amazon S3 bucket, AWS SAM supports 16 event sources for invoking Lambda functions. These event sources are configured as part of the serverless function and have contextual parameters based on the services configured. In addition to the event source, the Lambda function's permissions are also configured here. Lambda functions use IAM policies to gain access and act upon other AWS services. These can be inline policies written by you, AWS managed policies, or AWS SAM policy templates. Using an AWS SAM policy template, you declare the desired template and pass any required information for scope. In this example, I am giving the Lambda function read access to a specific DynamoDB table created within this template called SimpleTable. When setting up permissions, the best practice is to grant only the Lambda function's minimum required access to accomplish its task. This approach is called the rule of least privileges. AWS SAM policy templates help enforce least privileges by providing access levels from read-only up to full access. As a side note, AWS SAM policy templates work with state machine resources as well. As of today, over 70 policy templates provide various access to AWS services commonly used in serverless applications. To view the templates, visit s12d.com/sam-policies. Each template lists the privilege to be granted and any parameters required to scope the policy. When building Lambda function permissions, best practices are to use the AWS SAM policy templates or AWS managed policies first, and then inline policies as needed. AWS SAM automatically creates an IAM role for the Lambda function with a basic policy allowing logging to Amazon CloudWatch. Any policies declared in the AWS SAM template are also added to the Lambda's execution role. The next serverless resource is API. This resource creates an Amazon API Gateway REST API, which is also known as API Gateway v1. This resource allows you to create a REST API independently from a Lambda function. Use this resource when you need to do advanced configuration settings or place a REST API endpoint in front of a service other than a Lambda function or an AWS step function. In this example, I am creating a REST API endpoint with the stage name of prod. I declare an API, routing, and service integrations in an external OpenAPI file. Using OpenAPI gives me several advantages. First, I can prototype what I want in the Amazon API Gateway console and export the OpenAPI file for AWS SAM. I can also use OpenAPI to transfer a configuration to any API service that supports OpenAPI. Using a combination of AWS SAM model settings and OpenAPI, APIs can be fully configured for any application. With the API resource creating an API Gateway v1 endpoint, you might think there is a v2, and you would be correct. The HttpApi serverless resource creates an Amazon API Gateway v2 endpoint known as an HttpApi. Don't let the naming fool you. HTTP APIs are still a REST API, but built to be faster and less expensive. HTTP APIs do not currently have all the features of v1, however, the API Gateway team is working to bring parity between the two as fast as possible. The best practice is to start with HTTP APIs unless a feature you need is only on REST APIs. For a full comparison between the two, go to s12d.com/which-API. One of the main goals of HTTP APIs is to simplify the configuration. This change is most evident in how you configure core settings. In this example, I easily configure the methods of origin of my endpoint. Additionally, like the API resource, I use OpenAPI to configure routes and integrations. When creating HTTP APIs and REST APIs as standalone resources, it is possible to attach a Lambda function to the existing resource using the API ID parameter. This feature allows you to create routes and integrations through an OpenAPI template and add other routes and integrations through the AWS SAM model. The next serverless resource is the SimpleTable resource, which creates an Amazon DynamoDB table with a primary key or hash called ID. The table capacity is dynamic, and AWS manages the encryption keys. While these two lines of code are often all you will need, it is also possible to customize these parameters with the SimpleTable. What if you need to create a DynamoDB table with advanced settings like global secondary indexes? Remember, you can use standard Amazon CloudFormation resources in AWS SAM. The next serverless resource supported by AWS SAM is the layer version resource. This resource creates a new version of a Lambda layer. A Lambda layer contains additional code such as libraries, dependencies, or even custom runtimes that can be shared across Lambda functions in the same application or across multiple applications. To learn more about layers, go to s12d.com/layers. The application resource enables developers to import external applications into the existing AWS SAM model. The external applications are located in the AWS Serverless Application Repository, an Amazon S3 bucket, or a local directory on your machine. If referencing a template in an S3 bucket or a local directory, the template must be an AWS CloudFormation or AWS SAM template. When the application is packaged and deployed, the external application is transformed and included as a nested stack. The final serverless-specific resource supported by AWS SAM is the state machine resource. The state machine resource creates an AWS step function. The definition for the step function can be included in the template itself or referenced from an external Amazon States language file. In either case, AWS SAM uses definition substitution parameters to insert resource references into the definition. In this example, I create a Lambda function and a DynamoDB table that the step function will use. I define these resource values as definition substitution parameters, and AWS SAM resolves the resources for the step function to use. These are the 7 serverless-specific resource types available in AWS SAM. These, plus the entire library of AWS CloudFormation resources, enable you to build serverless, non-serverless, and hybrid applications using infrastructure as code. In the Tips and Tricks episode of this series, I cover more sections of the AWS SAM model. These sections include parameters for making the template reusable and globals to reduce redundant lines of code. I also dive into best practices for managing secrets with AWS SAM by using AWS SAM Systems Manager, Parameter Store, or AWS Secrets Manager. The next episode in this series covers using the AWS SAM init command to create your first serverless application from a starter template. I encourage you to watch it. Until then, thank you for watching. Again, my name is Eric Johnson, and you can find me on Twitter at EDJGeek. Have a great day, and remember, serverless for everyone.